Right, so yesterday we learned a little bit about standard deviation, and today I'd like to, we've got reasoning and we've got work that can be our evidence here. I want to look at these with some semblance of reasoning instead of having to calculate the standard deviation for all of them, because as you've seen, the process is a little bit lengthy. So let's look at this. Set G has a bunch of sixes. There's no deviation at all, and if we understand the standard deviation to be the average distance from the mean, then the mean is going to be 6 and the average distance is 0. So this is set G right there, and that's because this is the only one that doesn't deviate at all. Well, the average here, if we look at 2 3s and 2 9s, that's 6, 15, and 24. You divide 24 by 4 and you get 6. So the mean of this one is also 6, a very different set of data though. But half of the data is below by 3 and the other half is above by 3. So if we look at 6, the average distance from 6, well, these are 3 below, these are 3 above. The average distance is going to be 3. So that's this one here. Again, we didn't need to calculate anything. We were just able to kind of reason our way through each no deviation. Okay, each piece of data is 3 units away. Okay, so that's it gives you an average of 3. We look at this one here. Well, and this one, you know, there's only 2 pieces of data. The average is 15. That's 5 below and that's 5 above. So we can kind of use that as our excuse or our reasoning as well. And so the nice thing about that, if we know our sets of data, this one here, 3 above and 3 below, but you know, there's not a real great explanation for how this is the square root of 3. That would just be, this is the one where you would have to show your work, where I guess we could do that. Do that over here where we have space. Over here we have space. The equation, as you recall, standard deviation is equal to the square root of the sum of all x values minus the average squared over n. Okay, so there's 1, 2, 3, 4, 5, 6 pieces of data here. And if I take each one, and this will be a quick version of it, the average is going to be 5. Okay, we calculate the average by adding them all up. There's 10, there's 20, there's 30. 30 divided by 6 is equal to 5. So x bar is equal to 5. So if we look at all of our differences, x minus x bar, 2 minus 5 is equal to a negative 3. So I have a negative 3, and there's going to be 4 zeros, 0, 0, 0, 0, and then we say 8 minus 5, which is the x minus the average. 8 minus 5 is equal to a positive 3. Well, those are the differences, and according to this, I'm going to square each of those. So squaring each of those is pretty easy. That's a 9. We have the 4 zeros, and then we have another 9. After we square them, we find the sum, and if we add them together, that's equal to 18. If we add them together to get 18, we divide by n, which is 6. There's 6 items, divide by 6. That's equal to 3, and when we're done with that, we take the square root of that. So that's why this one is equal to the square root of 3. That's set J, and this right there is our reasoning and our work.